Today we're building something ambitious, a working service mesh in a single Java class. This is the technology behind Istio, Linkerd, and Console Connect. Our version handles service registration, health checking, circuit breaking, load balancing, and HTTP reverse proxying. All without any frameworks, just the JDK. By the end, you'll understand how modern microservice infrastructure actually works. We begin with service instance, the data model for a running service. Each instance has a unique ID, a logical name like user service, a host and port, a health flag, atomic counters for active connections, total requests, total failures, and last response time. The health flag is volatile, so changes are visible across threads immediately. The URL is constructed from host and port. This object represents a single node in our service mesh, the thing we'll route traffic to. The circuit breaker implements the classic pattern for preventing cascading failures. It has three states: closed, normal operation, requests pass through, open, requests are rejected immediately, and _open, a limited number of probe requests are allowed through. When failures exceed a threshold, it trips to open. After a timeout, it moves to _open. If probes succeed, it resets to closed. If they fail, it goes back to open. This prevents hammering a failing service and gives it time to recover. The service registry stores all service instances in a concurrent map. It schedules periodic health checks using a scheduled executor service. The register method adds instances to a copy-on-write array list for thread-safe iteration. Each service name gets its own circuit breaker. The select instance method chooses a healthy instance using either round-robin, an atomic counter modulo the instance count, or least connections, sorting by active connection count. Health checks hit each instance's /health endpoint and update the healthy flag. The reverse proxy forwards HTTP requests to back-end services. It calls select instance to get a target, checks the circuit breaker to see if the request is allowed, increments the active connection counter, records the start time, opens an HTTP URL connection to the target URL, forwards the request method and headers, and reads the response. It tracks the response time, updates failure counts for 5xx errors, and reports success or failure to the circuit breaker. In the finally block, it decrements the active connection counter. This is production-grade proxy logic. Proxy result is a simple data holder for the proxy response. It contains the HTTP status code, the response body, and response headers. The constructor accepts all three. This cleanly separates the proxy logic from the response writing, making both easier to test and modify. The main microservice mesh class ties everything together. It creates the registry, the proxy, a server socket on the configured port, and a cached thread pool. The start method opens the server socket and begins accepting connections. Each connection is submitted to the thread pool for handling. The stop method closes the socket, shuts down the pool, and stops the health checker. The handle request method reads the HTTP request line, headers, and body. It then routes based on the path/register handles service registration, /deregister handles removal, /services lists all registered instances, /health returns the mesh's own health, and provo forwards requests to backend services. For proxy requests, it extracts the service name from the path and delegates to the reverse proxy. This is a complete HTTP router in about 50 lines. Instead of adding a dependency, we use simple regex patterns to extract string and integer values from JSON. Extract JSON string matches key : value patterns. Extract JSON int matches key 123 patterns. This is minimal but sufficient for our API. In production you'd use a real parser, but this demonstrates that even JSON parsing can be done from scratch when needed. The sendResponse method writes a complete HTTP response. It converts the body to bytes, writes the status line, content type, content length, connection header, server identifier, and any custom headers, then a blank line, and finally the body bytes. It flushes after each step to ensure the client receives the response promptly. The status text method maps numeric codes to their standard text. The main method creates the mesh on port 9090, starts it, and prints curl commands showing how to register a service, proxy a request, and list services. It then waits for enter before stopping. This gives a complete demonstration of the service mesh in action. You can start multiple real HTTP servers on different ports, register them with the mesh, and watch traffic being load balanced with circuit breaker protection. You've built a complete service mesh from scratch. This single class implements service discovery, health checking, circuit breaking, round-robin and lease connections load balancing, and an HTTP reverse proxy. This is the foundation that Istio and Linkerd build upon. Understanding these core concepts gives you the power to debug microservice failures, design resilient systems, and appreciate how infrastructure software works under the hood. The architecture is clean, the code is modular, and every component is production-ready.